Okay, so in this lesson two, what we're doing is that we are still at the introduction part, but I want to check the last outline, which is the short circuit and the open circuit. I'm using this diagram within a space of 4 to 5 minutes to explain what short circuit is. Now, when we say short circuit, theoretically, it is a circuit of zero resistance. Theoretically, a circuit of zero resistance. So now, what happens is that when there is a short circuit in a circuit, that short circuit diverts to itself all currents that would have flown in adjacent branches. That is, branches hooked up to the same node, except branches without sources. So now, the short circuit within a circuit will actually divert all currents onto itself. In life application, let's assume this, that there is two roads. One of the roads is very, very, very long, and one of the roads is like very long and also very rough, and the other road is very smooth. In our normal world, the normal world we live, nobody will allow his car to pass through the rough road. No. Maybe that's the road that will lead to. It's very long and also it's rough. No. Nobody will allow his car to pass through the rough road. While there is a very well road he can pass. So now with short circuit, this is what happens. So the car coming is more or less like the current. The car wouldn't, or the driver driving, wouldn't allow his car to pass through the rough road where he experiences some resistance on the road. But I would like to pass through the correct road where there will be no or zero resistance. That's how it is. So the car here is more or less like the current. So now, when you check with short circuit, you have what we call the partial short and have the dead short. So now, these two examples will explain the partial short and the dead short. So now, the partial short is this diagram you see here. So this diagram A is giving the partial short. Why? Sorry, this diagram A is giving a dead short. Why? Now, when you consider this diagram, the short circuit you are seeing here is BJ. So the connection BJ is the short circuit. Why? This is because the current that is produced to flow within this circuit, these are all branches within the circuit. But because this place is short circuit means it has almost zero resistance or even zero resistance. So now, what happens is that with a dead short, the short circuit has zero resistance in the whole circuit. There is no resistance in the circuit because the current that is coming will pass through the short circuited region or short circuited connection without getting through any of these resistance or any of these sources or branches within the circuit. So now when the current gets to this point B, all the currents simply passes to this point B. This connection BJ, and it comes back. There will be no current going through R1, there will be no current going through R2, there will be no current going through R3. So in this case, the R1, R2, R3 are sent as the rough road. So the car will not allow itself to be passed on the rough road, but the driver will use the very correct route, which is the short circuit. Now, with this circuit, now the current produced here, that is, let's say, this first one is a dead short, so this one will give what? A partial short. Why? A partial short in the sense that when the current produced here will pass through R1, so it will obviously go through this rough road, which is R1. But when it gets to point A, it will only go further to R2, R3, or R4. It goes through the connection AB, simple, and comes back. So now R1, R2, R3 will experience no current, but the current will experience only a certain resistance within R1. So we say that it's the partial short. Now, what are some of the causes that brings about short circuit? One, you have insulation failure. So now you know that with the conducting wire, it has to be insulated. So when there's a failure, it can cause a short circuit. If there's a wrong connection within the circuit board, it can also cause a short circuit. And when you attach two live wires or fixes together, you are likely to also cause a short circuit. I think my other colleague that I'm taking this course with him, lecturing this course with him will come when we are doing effective resistance. We will explain how you calculate the resistance or the current, the total current, and those type of things with a short circuit or without a short circuit. But let's simply go through the open circuit and I'll end this lesson. Now, with the open circuit, it is very simple. You realize that with the short circuit, you are having no resistance or very small resistance depending on the kind of short. If it's a dead short, it's no resistance, but if it's partial, you have a very small resistance. But with the open circuit, it is represented this way on the circuit diagram. So now, if you have this as my circuit diagram, now, if this is simply my circuit diagram, what happens is that in this circuit diagram, when the current is flowing from this point going, when the current gets to this place, this is where we are having what we call the open circuit. So the open circuit is actually happening here. It is basically a branch within the circuit board where there is infinite resistance. There is infinite, the resistance is so big, like it's infinite. So we actually experience what we call what? A zero current. A zero current, like no current passing through an open circuit because there is an infinite resistance. So now, in simple, when you want to look at the difference between short circuit and open circuit, short circuit, you experience it is a zero resistance. There's zero resistance in short circuit. But in open circuit, there's a very big or large resistance. Short circuit, there's large currents passing through. But with open circuit, there is zero or no current passing through it. Thank you very much for this lesson, and I believe you really understand this lesson very well. The calculation aspect of this very course will continue in the next lessons. Just keep tuned and thank you very much. Bye bye.